Hi there. Thought we would take a look at the quiz over chain rule. So let's take a look. We've got 7 multiple choice questions and then 1 free response. So I want to make the most of our time here. Let's begin with the first one. We're looking at finding the limit as h approaches 0 of tangent, and then look at this limit. It should look familiar to you because it's in the same format as the formal definition of the derivative. So realize this problem never wanted you to actually work the limit, okay? I hope you're not thinking, oh, what was that tangent sum formula? That's not really what this problem wanted you to do. Instead, we know that a limit set up like this finds the derivative. So if we can find the function here, then we can easily find the derivative in a different way. So I want you to kind of zero in on this minus f of x because that's where your function is located. So looking at this, we can see that the function's actually tangent of 3x. So can we find the derivative of tangent of 3x in a different way? The answer is yes. So let's do that. Chain rule says that we have an outside function which is tangent of something. The derivative of that would be secant squared of that same something. If you're thinking, oh, I don't remember that, get you some note cards. Put those trig derivatives on the note cards because you're going to need to know them for the AP exam. Then the derivative of the inside, the derivative of 3x is 3. So I'll stick it in front because that's where it belongs. So it looks like we should get the answer D there. All right, moving along, let's look at number 2. We are told that the function 2x sine of x, what's the slope of the tangent line at the point where x is pi over 2? All of that code right there, what is the slope of the tangent line? It's really asking us what is the value of the derivative when x is pi over 2. So let's find the derivative first. Looking at our function, we're going to have to do product rule. So product rule says the first, which in our case is 2x, times the derivative of the second. The second here is sine of x, so the derivative would be cosine of x, plus the second times the derivative of the first, so times 2. Now we're going to plug in pi over 2. So we get 2 times pi over 2 times cosine of pi over 2 plus 2 times sine of pi over 2. So your trig functions, remember pi over 2 is the 90 degrees. We're at the top of the unit circle. So that's at the point 0, 1. That tells us that cosine is 0. Lucky for us, this entire term is going away with cosine being 0 there. And we know that sine is 1 at pi over 2. Again, if those values are not coming quickly to you, definitely draw your unit circle out. Get your trig values at each of the points where the unit circle touches the axes, because they're going to be ones you want to be able to readily know. So we do get 2 as our answer here. Okay, moving along. Let's keep going. So on number 3 here, it says when x equals -1, the graph of f of x, and then we have some options here. All of these options are asking about the function, but we are going to answer them based on the value we get at the derivative there at -1. So let's take the derivative. Now, first and foremost, I'm going to rewrite that function to have a 1/2 power instead of that radical. That's going to be easier for me to take the derivative. So we'll do that using product rule once again. So first times the derivative of the second. So bring your 1/2 in front, x plus 2 to the -1/2. And then, of course, the derivative of the inside, the derivative of x plus 2 is just 1. Now plus, And we've got the second here, which would be my x plus 2 to the 1/2 times the derivative of the first. So the derivative of negative 2x is negative 2. Okay, let's clean it up just a bit. I'm seeing these 2's will cancel here. Don't want to lose the negative, but the 2's will cancel. So I've got a negative x on the numerator, and on the bottom, I've got an x plus 2 to the 1/2. Then I've got plus x plus 2 to the 1/2. And I've got that times a negative 2. All right, so what we're trying to do is to determine what's happening to this derivative at negative 1. So I'm going to plug in negative 1. So negative 1 is just a 1 over negative 1 plus 2 is 1 to the 1/2 is still 1 plus negative 2 times negative 1 plus 2 is 1 to the 1/2 is still 1. So it looks like I have 1 plus negative 1, which is 0. So what does that mean for my function, right? Is it undefined? No. Is it increasing? That would mean that the derivative was positive. Well, no, our derivative is not positive. Our derivative is 0. Derivative negative, is it decreasing? That would mean the derivative is negative. Does it have a vertical tangent or horizontal tangent? Well, if the slope is going to be 0, that means we have a vertical tangent there. Okay, let's take a look at number 4 then. What is the slope of the normal line? So remember, normal line means that it is perpendicular to the tangent. So we're going to take the derivative, find the slope of the tangent, and then we're going to create a perpendicular slope. Which if you remember, and the reason I'm doing this is because you remember from Algebra 1, perpendicular slope. So we flip it and change the sign. So let's get the derivative first. Let's find the tangent. So it looks like I'm going to rewrite g of x as x squared minus 2x to the 1/2. So we can take the derivative of that. So 1/2 times x squared minus 2 to the negative 1/2 times, and then take the derivative of your x squared minus 2x, which would be 2x minus 2. Now clean it up by looking at what goes to the top and what goes to the bottom. It looks like only the 2x minus 2 is going to the top. We've got the 2 from the 1/2 coming to the denominator, and I've got the x squared minus 2x to the 1/2 coming to the denominator. Now, I do realize I could factor out a 2 in the top, cancel it with the denominator. I'm not going to do it on this problem only because we're just plugging in a value for x. So I'm going to put in a 4 for x. So I've got 2 times 4 minus 2, which is going to give me 6. Then I've got 2 times 4 squared is 16, minus 2 times 4, which is 8, and that's to the 1/2 power. Okay, so on the denominator, I've got 8 to the 1/2 times 2. So I've got 2 times the square root of 8. Now I know the square root of 8 can reduce to 2 on the square root of 2. So that becomes 4 on the square root of 2. Think about it. I had a 2 there, and then I changed the square root of 8 to 2 times the square root of 2. So I've got 4 because of the 2 times 2, and then I've got the square root of 2 on the bottom. Okay, look at my 6 and 4. Those will reduce to 3 and 2. Okay, now remember, this is my slope of the tangent. So I've got to flip it now and change the sign. So if I change the sign, it becomes negative, and I flip it. Okay, well, the only ones that are negative are D and E. So I know A, B, and C are out. That won't work. And then it looks like they left the square root of 8. They didn't simplify like I did. So I'm going to go with E. So nicely done. Watch your wording with this, the normal line. Okay, let's look at number 5 then. We are just straight up finding the derivative on this one, looking for the quotient rule. So remember low D high minus high D low over low squared. Just a phrase that helps us remember. Low means the denominator. D high means the derivative of the numerator. Minus high. D low, derivative of the denominator, all over low squared. All right, now the fun's going to be in simplifying this because look at these answer choices. Looks like they've multiplied it out. They've probably done some canceling. So we're going to try to do that as well. Okay, let's straight up do some foiling. So I'm going to multiply these out. That gives me 18x to the third plus 3x squared minus 6x squared minus x. Now, I'm not going to distribute this minus until after I multiply because I'm going to worry about the multiply part first. That's going to give me 18x to the third minus 3x squared plus 6x squared minus x. I try not to do too many steps all at once because then I make mistakes that way. That's why I'm going to wait and distribute this minus to the second parentheses in my next step. Now I'm going to go ahead and combine these two together. It's going to give it a negative 3x squared. And then I'm going to distribute my minus. Makes it a little bit easier when we come up and start collecting like terms. Okay, so look at what I've got. I've got an 18x to the third going away. I've got a 3x squared going away, and I've got an x going away. Woohoo, that did a lot to help us. So now I've got negative 6x squared in the denominator, and I've got 3x squared minus x squared. Okay, now look at your denominator. It looks like they have an x in common, but when I pull it out, I got to be really careful. Let me show you what I mean by that. So think of this all being squared, and then inside we're going to pull an x out. Okay, now each of these is being squared. So that's x squared, and that's 3x minus 1 squared. I think that's the part that probably stumped a few people. So seeing that, you can see that the x squareds cancel, leaving me with c, negative 6 over the 3x minus 1 squared. Okay, so watch the algebra. Remember, sometimes the calculus is the easiest part in the problem, but the simplifying with the algebra is what gets us, and we make mistakes. Okay, let's look at number 6 then. We're going to take the derivative, right? You might want to rewrite this one only because you've got theta to the 1/2 power. So when we take the derivative, that gives me 2 times 1/2 theta to the negative 1/2 plus, and then derivative of 3 cosine is negative 3 sine. Okay, so it looks like, look at the 2 and the 1/2 are going to cancel. Then I've got theta to the negative 1/2, so that's 1 over theta to the 1/2. And then I've got plus negative 3 sine of theta. Now look at my answer choices. It looks like they have formed a common denominator. So our common denominator is the only denominator we have, which is theta to the 1/2. So it looks like I'm going to need to multiply this second fraction times theta to the 1/2 over theta to the 1/2 to form that common denominator. And then I can write them together as one fraction. And that's how we get D. Okay, Again, I think a lot of people get caught up in the algebra, and that's where they tend to miss it. Okay, in the cleanup, they may have gotten the calculus part right, but then in the cleanup, to make it look like the answer choices sometimes can get students. Okay, let's look at number 7. So we've got the graph of f of x. We've got a table for g of x. Ooh, this is going to be a fun one. And we're told what h of x equals. And we're asked for the derivative at -3. So let's take the derivative of h. First, I'll rewrite h as f of x times g of x to the 1/2. Okay, chain rule says 1/2 times something to the -1/2. So we know that's our f of x and our g of x in there. And then when we multiply by the derivative of the inside, we've got to be very careful because that's a product rule. That's first times derivative of the second plus the second times derivative of the first. And now we are going to find all of these values at -3. Okay, so when we look at the graph of f, we have to realize that f, if we're asked for a value of f, then we're just looking for what is the y value. But if we're looking for f prime, then we are looking for the slope. So we'll be really careful when we get these values to make sure we're using the correct one. Okay, so f of -3, that means we're going to the graph of f at -3. We want the y value. That's 2. G of -3, a little bit easier. We just go in the chart. For g of -3, that's 4. And again, to the -1/2. Okay, then I've got f of -3. We did that. That's the y value. That's 2 times g prime of -3, which is -2, plus g of -3 is 4, and f prime of -3. So go to your graph. At -3, we want the slope. So you're going to calculate rise over run. Looks like it goes up 1 over 2. So that's a half. All right, now we just got to clean up the numbers here. Looks like I've got 1/2 times 8 to the -1/2 times -4 plus 2. Okay, the 8 to the -1/2 is coming to the denominator. So I've got 2 square root of 8 times -2. Okay, so those 2's you can see cancel, and that leaves me with -1 over the square root of 8, which I have as an answer choice for A. Okay, so very important when you're looking at those graphs, make sure if you're looking for the function value, you're getting the y value. If you're looking for the derivative, you're calculating the slope, count it just like you would in algebra, rise over run there. All right, friends, so far so good. That wraps up the multiple choice. Let's look at the free response. So we're given a function, 2 functions actually, and we're asked, I'm going to go ahead and rewrite f with a 1/2 power. And A, we're asked to find the equation of the tangent line of f. Important that we use the right function. We can do that. We did that in one of our multiple choice questions. So I'm going to find the derivative using chain rule. That's 1/2 times the 2x plus 1 to the -1/2 times the derivative of the inside. The derivative of 2x plus 1 is 2. You can see the 2 and the 1/2 cancel. So we end up with 1 over the square root of 2x plus 1. Now we need the derivative at 4. So we're looking for f prime of 4. So that would be 1 over the square root of 2 times 4 plus 1. Or 1 over the square root of 9, which would be 1/3. Now make a note to yourself, this is the slope of your tangent line. We need that. We also need the point. So we need the point at x equals 4. So we're going to go back to our function, and I'll probably use it in the square root form, and we're going to find the y value. So that tells me that f of 4 is the square root of 9, which is 3. That means we're going to use the point for 3. Let's put that all together for the equation of our tangent line. Y minus 3 equals 1/3 x minus 4. And that's the equation of my tangent line. Okay, moving along then, notice in B, we're asked to find the equation of the normal line of G. So we talked about normal being the perpendicular to the tangent, but let's start with the derivative of G. So G of x was cosine x. So G prime would be negative sine of x. And we need this value at pi over 6. So we're going to put in pi over 6. Now remember, pi over 6 is a 30-degree triangle. So if you need to draw it, that's all good. Across from the 30 is the 1. The hypotenuse is 2. And the long side is square root of 3. So you can see that the sign is opposite over hypotenuse, and I get negative 1/2. This is the slope of my tangent line. It is not the slope of my normal line. The slope of my normal line would be 2. Remember, I flip it and change the sign. So I've got my slope. Now I need my point. Just like we did before, we need the point at x equals pi over 2. So we're going to plug in pi over 6, excuse me. I think I said pi over 2. We're going to plug in pi over 6. And lucky for us, we've already got the triangle drawn. So we can see that cosine is adjacent over hypotenuse. So I know that I have my point at pi over 6 square root of 3 over 2. Now I've got my slope for the normal line. I've got my point. I can write them all together. I have y minus square root of 3 over 2 equals 2x minus pi over 6. And that's the equation for my normal line. All right, one more part to go. Next, we are introduced to a third function. Suppose that f of x equals g of x times f of x. Is h of x decreasing or increasing or decreasing at x equals pi over 2? Okay, so we're going to need that derivative. Let's start with the derivative. It looks like a product rule, so I'm going to do first times derivative of the second plus second times derivative of the first. And I need to go ahead and put in my functions. Now remember, from our work we've already done in part A and B, we have these derivatives, okay? And we have the functions. So let's put them in. I've got cosine for g of x. F prime of x, remember, we found back in part A, 1 over the square root of 2x plus 1. A lot of times, when we do a free response question, we see that they build on each other. So don't try to waste time like reinventing the wheel. Use the pieces and parts that you already have to help speed along the process. Okay, so there's my derivative. Now we want the derivative at 3 pi over 2. Now remember, that's 270 degrees. So we're down at the bottom of the unit circle. Cosine of 3 pi over 2 is 0. So I'm not even going to worry about this one because it doesn't matter. I'm going to multiply it by 0. Then I've got square root of 2 times 3 pi over 2 will be 3 pi plus 1 times, and then sine of 3 pi over 2 is negative 1, but this sign is negative, so that's a 1. So here's the deal. It looks like I'm going to get the square root of 3 pi plus 1. Don't bother trying to figure out what value that is. It doesn't matter. All that matters is that is positive. Because that is positive, we know h of x is increasing at x equals 3 pi over 2 because h prime of 3 pi over 2 is positive. Okay, very important. We showed our work, but remember when AP says give a reason for your answer, this is the golden sentence, right? Don't leave out any part so that make sure that you get all full credit for the parts of this one. I hope that helped with your chain rule here. If you'd like to see more videos, feel free to click subscribe so that you're made aware of when I post more videos. Thanks so much. Bye for now.